Hello, welcome to my edition of Mr. Hofman Math. Today we'll be talking about 2-6 adding and subtracting terms. I'm going out of order with these lectures, but that's because I thought it was better to go out of order a little bit and to do it the way that we did it in class previously. So with adding and subtracting terms, to rewind a little bit, we already learned about multiplying within terms. So simplifying a term by multiplying or dividing. Now adding or subtracting terms. So suppose that you have several simplified terms. You've already done the multiplication and division. They're all as simplified as they can get. And these terms I'm going to bracket, and they're each going to be connected by a plus or a minus symbol. All right, and suppose that this term is, one is 2x, the other is 3y, and the last one is 5x. All right, so each of these terms has an identity that is defined by the variable. So it is what its variable is. And the best way I can demonstrate that is by drawing with colors. So anything that has an X, the X is automatically going to make it red. It's sort of like when you add Kool-Aid to a cup of water. The Kool-Aid is the variable. The number is the amount of cups that you have. So the Kool-Aid of X turns the entire thing red. So that is a red term. You could say 2 cups of red Kool-Aid. Over here, we have 5 cups of red Kool-Aid because it's the X again. So we have 2 reds right here and right here. And then we have Y. Y is going to be a different color. If X is wild berry, then Y is going to be, we'll make it blueberry. Blueberry Kool-Aid. So Y makes that entire thing blue. All right, now that we've color coordinated it, we can check to see if any of these terms are able to combine. Here's the way that you can tell if you have what we call similar terms. Similar terms occur when 2 terms are the same color. We have a red, we have a red. So 2x, then take away 5x, because there's a minus right there, is like having 2 cups of water, then you drink 5. Now obviously it's unrealistic because it would put us into the negatives. Well, in our math sentence, that's exactly what it does. It puts us into the negatives. 2 cups minus 5 cups is going to be negative 3 cups of red. And then for blue, this blue cannot combine with anything else because it's the only blue color there. So we're just going to leave it as it is. We're adding 3 cups of blue, so we're still adding 3 cups of blue, or 3y. Therefore, this statement can only be simplified into negative 3x plus 3y. All right, so what we learned from that past example was, first of all, when combining like terms, you can only combine like colors. In other words, you can only combine terms with the same variable. All right, so now I'm going to show you a few different ways that a problem might try and trick you. The first one is if there's more than 2 variables in a term. So suppose you have 2xy, and then you are adding 4yx, and then subtracting 3. All right. So what do these mean? First of all, you have 2 terms here which have the same variables in them. However, the variables are in different order. Now, what you learned in the last lecture is that when simplifying a term, you need to have the variables in alphabetical order. So this is actually 4xy. All right, now we're going to decide what color these are. Now what happens with Kool-Aid when you combine a little bit of blue with a little bit of red? What happens is you get the color purple. And so to demonstrate what purple is, we aren't going to get it perfectly here. We're just going to put a blue and we're going to put a red around it. And that blue and red combine to make purple. All right. So similar over here, we have a blue and a red. And the blue and the red make purple. Therefore, these are both purple statements, which means we have 2 cups of purple, 4 cups of purple, or we have 2xy plus 4xy. Those are the same term. Therefore, we should have 6xy. Now we have one term over here that doesn't have a variable in it. Suppose that you have a cup of water, 3 cups of water, like we have here, but you don't add a variable, so you don't add any coloring. What happens is that color is just clear, invisible. And so this actually, you can identify it as a color, just the color is invisible. In this case, we don't see any other invisible or colorless terms, and so the 3 can't combine with anything. Therefore, we just have -3 at the end. All right, we got 2 more. In this one, we have 3x squared plus 2 minus 6x plus 5. We might be able to identify colors. We know for sure that the 2 and the 5 are colorless. But how about the 3x squared and the negative 6x? Now, in Kool-Aid, if you were to put an x into the negative 6 cups, you would get what color was that again? Like a red, we'll say x is red for this example. You would get a red color. However, what if you were to put 2 pinches or 2 scoopfuls of Kool-Aid rather than 1 like we did there? This color would actually be a darker red. So I'm going to make the circle just thicker. But imagine that what that means is this is a darker red. These are not the same color. This is darker, this is lighter. In other words, 2 x's cannot combine with a term that has just 1 x. So therefore, this is just 3x squared. It can't combine with anything here. And then you have these 2 terms which combine to make 5, 6, 7. So plus 7. And then this last one, minus 6x, which is going to be a lighter red. We would like to rearrange this so that any number, any colorless number, is all the way over to the right. And so the actual equation would be 3x squared minus 6x plus 7. That is your final answer. This looks crazy. That's because it is. And I'm going to actually stop using the color explanation because it'll just make this more confusing than it used to be. All you need to know is that in order to combine terms, they have to have the same arrangement of variables. This is 3x divided by y. This one is 2xy. This one is 3y divided by x. And this one is x divided by y. So what I want you to look at is the arrangement of the variables. You have an x divided by y. Do we have any more x divided by y's? There's one more over here. Therefore, those are the same term. This one is y divided by x, so it is not the same as x divided by y. Therefore, you do not combine this with either of these. This one stays alone. And then this one obviously doesn't look like the rest because there is no dividing by. So this is, so in this situation, you only combine these two terms. Now the question is, how do you combine 3x over y's and just x over y? Whenever you have any variable that doesn't have a number in front of it, what that is saying is that it is an assumed 1. There's an x over y here. 1 x over y. So you can actually write a 1 in front of it if that helps. So we have 3x over y plus 1x over y, which is going to equal 4x over y. One other thing is when I put a number on top and when I put a number in front, those are the same thing. If 3 is on top, that can be rewritten 3x over y. The only way it can't be written is x over 3y. That is a no-no. So this is not the same as these two. So then we have this plus our 2xy plus our 3y over x. And this is our final answer.